Hi, in this video I am going to go through the questions from week 4, 2024, fall semester. These are questions from the classroom, not from the poll. Poll will be a separate video. This first question is asking you to import the data set using a tool like read.csv or read.delim. It really more matters on how you download the data. So the different ways that you would download that will result in, let me move my little head. Bye-bye. I'm still here, don't worry. Oh, that got weird. So regardless, you needed to get that in there somehow. So you would have downloaded it from like Google Sheets, then you would upload it. Once you'd uploaded it, you might be tempted to come down here and click on it. The problem is, if I open it down here, it opens as a text file, not as an object, and that's a problem. If you right click on this, or I don't know, sometimes people find different ways of interacting with this down here. But the problem is that they'll sometimes use non-base R packages, which those packages are wonderful. They often do a great job of structuring the data. The problem is it won't work with all like kind of different types of packages. And that's just because they are structured slightly differently. So those are usually people are going to be using read R for that. So that's not what I recommend, at least for this class. I recommend the base R importing. When you do that, you get this visualization. You customize it based on what's going on down here. Well, this has a heading. I need it to make a heading, so that should be yes. If this was not the right type of delimiter, that wouldn't work. It needs to be the right delimiter for whatever you downloaded. So I downloaded a T tab separated values table, not a C comma separated values table. And so for me, I need that T to match the tab that I can see right inside of here. So I do that. I will usually change this right here to whatever I want to name the object. And the reason I do that is that if I put all of those steps together, it writes the code for me. I copy and paste it. Boom, there it is. So this was my version that I uploaded. That was more just to make sure everyone could get caught up. But read.delim or read.csv. If you have an underscore here, it means you use that other package. I don't want you doing that because that will change some downstream interactions. Cool. At this point, I then asked you to order the data by the Panicum Hollii gene name. So that's going to require you to use an indirect measurement. So you use order to analyze a vector, in this case, just the gene name. That's going to put these gene names in order. Anything that did not match that order will be placed according to the original order. So we can see that. This is what it looks like before. Let's do a head function just to look at the beginning of that gene. Well, let's get just a little bit more. There we go. So we can see actually at position 7, I knew that because I looked at this order functions output. So right here. So position 7 is actually what should be organized first if these have been alphabetized. And so if I extract position 7 and then I extract position 1 and then I extract position 51, which we can't see right now. If I extract them all in that correct order, get it? It will put them in order. Right, so that's what's happening here. I'm using the output of order to reorganize the data. If I now repeat, so I'm pressing the up arrow key, if I repeat that head function, I can see that it has in fact been sorted. So this was what it looked like originally, and now it's all nice and pretty. That is the order function. Very important, it also allows you to have multiple arguments. So I could keep on adding more and more arguments to sort anytime there's a tie. So for example, there is a tie right here. In this case, because this one came first from row 1 before whatever row 51, which is where this one came from, this row 1 gets priority since they were otherwise tied. But had I done something else, like maybe stu_df integer, it would then break that tie based on sorting that second vector. All right. Cool, this toolbox, I'm not going to go through, I went through that in class. I was just going to go through some of these answers. This first one is creating a column called init rows. That's what's happening here. Before this line of code has run, this is an empty container. So we can actually refer to empty containers. Note, you can't do it using the single square brackets tool. So this run by itself produces an error, which actually can be nice. That means that if there's a reason why that doesn't exist, that can help give you information. But it also does still allow for you to assign data to it. So that can be a strategy. I am, in fact, usually assigning to $sign. I like $sign because it lets me have this little interactive box that I can access by putting my cursor to the right and pressing tab. That's very handy. Anyways, when I started off, it was empty. I then assigned it new values. This is what we call a left-hand assignment, where I am extracting the data I want to either create or change, and I am assigning it new values. So even though init rows by itself isn't an object, it is now the name of a container inside of the studf list type object. And so assigning it values from the row names ends up storing those values inside that container. Since I have stored a similar length of data that is actually still organized into a handy little data frame, which has rows and columns, because each of the contents of the containers are the same length. That's a lot. That's why it all works, though. So, in summary, extract what you want to change or add, assign it the values you want to change those values to or to add. This next one is then doing a similar thing, but this time we are changing the row names. So again, we're getting the data we want to change, and then we are assigning it new values. Now, I do have to stress, not all functions allow you to do this. This is like a special ability of certain functions, like our extractions, and functions associated with attributes, like our row names. I have more of a list up here. There are more I haven't listed, but these are the most common functions that I will be assigning to. It's what we call a left-hand assignment. It's not a super common thing, but it's a very important skill. Okay, so question one. Question one is asking you to make all the column names lowercase. So if I want to change, if I want to change the row names, to change the column names, I first write code that pulls out those column names. I generate the new names I want to apply to it. When I run that assignment, I've now overwritten the column names. And if I print them off just to check my work, I can see it worked. They are all now lowercase. Nice and simple, exact same concept as up here. A little bit simpler because I wasn't using paste O, which is a little bit of a challenging to understand function. It just sticks strings together. It's not too bad, although there are some modifications that make it quite tricky once we really start using it. I use paste O all the time, constantly. All right, question two. Question two asks you to make all of the color column values. So if I want to change the values inside the column, much like before when I was extracting, what was I extracting? Init rows. Much like when I was modifying init rows, I will extract the column I want to change, not create this time, and assign it new values. I hope you're noticing a trend here, but that's going to work. Same thing for the video game column. This is what it looked like before. Not a lot of capitals, but we can see the P and the G there. Once I've run this, those are all now lowercase because I've overwritten their original values with the lowercase version of those same values. The next one is trim white space. Going to operate in a very similar fashion. I'm going to extract each of the values I want. Currently, there is a value called rainbow with 2 spaces at the end. Trim white space is a handy little function, helps you get rid of spaces. You could have used a G sub for the record, so y'all should have already seen that. But what trim WS will do is it will remove white space from both the left and right side. So both being the default option, but you could have specified left or right. And this is just a common way of communicating to people the three possible options. And typically when they do this, it is the left option that is the default. So you can see that both is the default here. This is kind of their shorthand way of saying that. It's somewhat common, it's not super common. Next one, make a column named integer underscore clean that produces some error messages. And what are those error messages? So let's take a look at the integer column to start off with. Look at this, we got one big old character vector, somewhat big character vector. That one turns out to not cause a problem. The word integer itself, and then some other like kind of silly answers. So like this empty character, someone who just didn't add anything into that value. Well, when we run as.integer, some of those will work, some of them will not. If I kind of scroll up, I can see that that one that was an empty character did not work. One of them that was just the word integer did not work. It was not able to be coerced, so that was at position 11. Let's see what that was. Oh, that was the word integer. Position 23. A very long vector. It turns out long enough that it's unable to store the integer in a integer vector. And that's just because there's a finite amount of accuracy to integers. And so if I exceed that, so this is not 1,000, not million, not billion, but 1.9 trillion is apparently too large to fit into an integer vector. And then this is much too large to fit into an integer vector. This one's large, this one's small enough. This one can be fit into an integer vector. But the other two were too large. So those other two that were just simply too large, they're outside of the range of values able to be stored in integers. How would you know that? Maybe research this warning message, or go up here and just kind of look through and be like, hey, it's the bigger numbers. What's up with that? And then maybe you could do some research and it would kind of explain this message. The other one is just kind of a generic message that I see, and you'll get used to seeing. This one's pretty common, of simply where there is no way to convert the word integer into an integer, and so it doesn't try. It introduces a missing value. All right, that's been stored. Next up, do some math. So this is just math. Nothing too hard there. Common mistake will be to just do log. It turns out there's a difference between log, which is the natural log, log 2, which is the log base 2, and log 10, which is log base 10. So it's going to give us orders of magnitude, or a function of the order of magnitude. And so we can see like here is 10, and there's probably a couple other 10s in here somewhere. We can see some zeros or other values. Next up, we've got, sorry, not 0, 1. My bad. I do that. Jeez. I've been teaching all morning. It's fine. All right. If I then wanted to create a histogram, I can see that it looks okay. Because we did have such a large number is why I was having you do that integer transformation. If I hadn't done that integer transformation, so I had just done the integer column, and I had converted it as dot numeric, I get this incredibly large value if I make that as dot integer, which if you are thinking carefully, you'll realize this is that value that was enormous, and so every other value is way down here. While storing it as an integer, I'm at least able to get out to these 6 orders of magnitude, but I can still barely see one other pretty big number, and then the rest have all been lumped into one bin. However, doing a nice log transformation, I'm able to spread those values out a little bit better and at least understand them. There's actually a number of different ways to do log transformations in visualizations, but for base R, actually transforming the values is the easiest way. Once we get to ggplot, there'll be some nicer ways of visualizing it. The next one is just getting you to visualize using a table. So tables are interesting, but they do have the problem of, if you're visualizing text, like values, the value itself is often hard to see compared to the number. And there are some ways around this. I could do things like add in symbols to help me understand it. So I could use paste-o. So I could say integer this. And so what I've just done is I've converted all of these into strings, but now they have a letters at the front, so it's obvious which one they are. Then I could call table. All right, now it's much easier to read and interpret and realize that things like integer 4 had 8 occurrences, so it was our most frequent value. Just some handy lines of code. One time, don't have to go to the next class just yet. So this next one is just exploring the data after ordering it. But the challenge was to first sort by the clean value, then anywhere there was a tie, so for example at where there was a missing value, it should then sort by the original information. So that is what this is doing. So that is a nested sorting. Again, I'm using the output of order, which now that I've run it, that order's changed. And so now, like if you look through these, they're just in order because I've already reordered STUDF. But before I had run this line of code right here, before I had run this, this would have been very different numbers based on the original order of the data frame. So anyways, once I visualize that, just to check out to make sure it worked, I can clearly see my integer clean column increasing. If I look wherever there is a tie, which I believe will be at the end, so the head, there's not any ties that need to be broken. But if I look at the tail, where I had some values that were unable to be coerced, I can actually see that these have been sorted. They've been sorted as if they were character vectors, though. So this is only above this one, or sorry, is only below this one, because that the one I've currently got highlighted had a 1 at the beginning, which is going to be lower alphabetically than something that begins with a 2. Integer had been sorted below in an empty character vector. I honestly wouldn't have guessed this. But since that was tied with the rest of them, it actually ended up sorted above the numbers. And you wouldn't have memorized that. You would have just kind of learned it through experimentation or through memorizing over a long career using these types of skills. All right, number 7, print off just the rows where studf integer clean has missing values. Use is.ina to generate the vector for extracting. In fall 2024, this was 5 rows. We're still in fall 24. So the easy thing is just to detect the presence of missing information using is.ina. It used to be a little bit harder to find ina values. I think this still does, in fact, return all missing. Yeah, it used to actually give you a warning, which was kind of nice, but this is the problem, is if I try to compare something to missing and to detect true or false if it's missing, everything becomes missing, because that's what happens when you do a comparison with ina. And so there is a standalone function for detecting the presence of missing values because it is just hard to work with. And so if I do that, if I run is.ina, that's going to return true. If it's missing, I then use that in the extraction, and bam, there it is. I've pulled out my rows that have missing information in the integer. So it's those 5 rows. That's it. That was a weird sound. Don't know why I made it. All right, this next one, it says, how many people put an empty character vector for their favorite video game? So there's a number of ways you can do this. This is probably the easiest. Here I have done some logic. I do want to point out that there is a missing value here because one person just put NA, literally, as their answer, which for the record stands for not available, not applicable. Some people put n/a, which they may have been intending not applicable, and that would probably be a little bit more appropriate. But that just kind of gets at that interesting concept of there being a difference between missing data, not available data, data that we just never get to observe because that student was absent that day. There's different forms of missingness that you may not have encountered because you haven't worked with real data enough. And so this is just kind of giving you a little bit of that idea. Anyways, once I have this, if I want to calculate how many trues, again, there's a large number of ways to do this. I could call which on this, which would give me the positions, and then I could call length on that. That's one way. It's a little bit convoluted. Because logic can be coerced into zeros and ones, I could convert this into a number using the sum function. The problem is that missing value in there means that I now have like 0 plus 0 plus 0 plus 1 eventually, and 0 and then 0 and then 0 and then like 1 again and so on. But eventually there's an NA, and so anything with an NA added to it becomes missing. Like there is no sum of that. And so in order to actually call the sum of this, you'd either have to do this comparison, then remove the missing value from the logic, or simply use the built-in argument missing.remove. You also could have just looked at a table as long as you had this if.any will show the missing information. If we scroll on up and we see this right here, we can see the number of people who put nothing, which obviously doesn't print off well. And so that is a little bit challenging, although there's plenty of ways to get this out of here. You could even, I believe, do an extraction. No, it did not allow me to do that. I'm actually a little bit surprised. That's kind of fun. That makes me happy. It's nice when I'm still getting to learn things, Anyways, it's hard to work with the absence of things. And so this is why I'm using it as an example, is that this kind of example makes it a little bit easier once you run into it. Oh, it's not a space, it was nothing. Let's see if that works. Yeah, still doesn't work. So, like I said, still get to learn things even at this point. Anyways, moving on to the regular expression examples, and I may actually have to pause this recording. You know what, I'm just gonna publish this one and I'll go through the rest of these examples in another video. So hopefully that helped. Bye. Made that weird sound again. Don't know what that's about.